Right, yeah. A storm event on a 300-year return time, because that's what we were talking about. Storms of that ferocity seem to return about every 300 years. But that's nowhere near enough to explain the kind of diversity in woodlands. But he gave a clue. And actually, that clue is that it's just an example of one form of natural disturbance. There are many other forms of natural disturbance, and they all work together to kind of be the counteracting force of vegetation succession. And the sort of things that also work as natural disturbance agents are these great big beasts. Now, these are from the northern hemisphere, so it's not just Britain, obviously, but it gives an idea of the size of the beasts that used to be roaming around in the northern temperate zone, basically causing disturbance. Now, I think a long time ago, people used to think that these beasts lived in the forest. Well, they did, but they didn't just live in the forest, they drove forest ecology. You know, a herd of these big beasts. Look at that bison on the left there. The one at the right-hand end, that's the normal-sized American bison. That's not small. The one on the left-hand end, which I think was in the steppes of Russia, if you had a herd of those going through the forest, it would leave some mark. So you had these big beasts. And actually, if anything, this interglacial period, the big beasts we had roaming around were even smaller, more even than the ones that were in the previous interglacial, where we had elephants in this part of the world. So the idea that we have big beasts roaming through the forest actually having an impact, that's the natural state of the northern temperate zone. Big beasts having a big impact. Problem, of course, is most of them are extinct. And actually, even the ones that aren't extinct, you may not want because they're rather large and rather vicious. So the idea that we can just bring back lost species and restore the natural processes or the natural process of grazing and browsing using wild species doesn't really work. We can't really do it. What we can actually do, a phrase I use quite a lot, is we can actually bring back proxies of wild animals. These are domestic proxies of wild animals. And this is the mix of animals that we get in the Nep estate. And I'll just mention a few of my favorite ones. You can see the array there. The point here is that mostly they are domestic animals. Right? Well, they are treated in the same, or we have the same responsibility that we do have for domestic animals. But they're not wild animals, with exceptions like rabbits and roe deer. But mostly these are animals which are domestic, but they are proxies for wild animals. And here's a couple of examples. So we have the Tamworth pig. The Tamworth pig stands in for the wild boar. The wild equivalent would be the wild boar. Now we brought the Tamworth pigs in there, and very, very quickly, these domestic animals start to behave just like their wild ancestors. Now, we didn't know how much a pig ploughed. One sow can plough 40 acres in a year. Part of Nep, where this rewilding is done, is about 800 acres. There are only 6 pigs in 800 acres because of the impact they have, plus their piglets. And you can see what they do here. They shovel things around. They behave like hippos. They actually manage to find grubs and things underwater, which we didn't know about. They do have a massive driving impact. They don't just live in forests. They are actually a driving force of forests. Other animals, the heavy hitters, the deer. There are 3 species of deer at Nep. This is the red deer. There's also the fallow deer and roe deer pass through. And these have a big effect. We didn't know how much they liked water, so they keep the waterways open as well. Yes, they graze and browse, but they also have other effects, like they're fighting and jousting. They open up areas by simply the fact of them pouring the ground and attacking each other and defending an area. It has an impact on the landscape. Other species, the ponies. All of these things graze and behave in different ways when they're given the opportunity to do so. They choose what they eat, different times in their life cycle, different times of the year. Therefore, they have a different effect on the landscape. They're not just forced to eat one species of grass. And if you look at these, they're actually being quite selective in what they eat. Some times of the year, they'll choose very twiggy things. At other times of the year, they'll go for much more lush grassland. So they all behave in different ways. And in a rewilding project, they're allowed to. They're not just forced into eating lush grass. And my personal favourite are the English longhorn cows. These are great. They look big and savage, but they're pussy cats. They're really, really nice. And here we see it's not just true that cows spend all day eating green grass. They don't. Look at this. They're all choosing, in this case, to eat very twiggy materials, which they do at certain times of the year. They do naturally go for a balanced diet. They browse as much as graze. And they have other effects, like the deer. They rub their horns or their antlers up and down the trees, which can kill some of the trees and could end up reopen the forest. So you've got all this going on. Right, so let's have a look at this kind of model that a lot of you have probably had in your mind. You think of the idea we have new habitat, and you go through this process of succession. Little trees turn into big trees, and then you get mature habitat. And then if that carries on, you end up going to climax forest. And I guess a lot of you have heard the phrase climax forest, and you've probably heard the phrase climatic climax forest. This was an idea that until the 1960s kind of held sway. That was supposed to be the end point, that the idea for every climate zone, there was a climax forest that it headed towards. Yes, but it's only part of the story. It's not the end point. What actually happens is, yes, that's part of the equation, but you have this more cyclic arrangement where natural disturbance is turning the clock back on succession all the time. It's actually multiple scale and multiple time scale. This is just a simplistic representation. And what causes disturbance? Well, grazing and browsing is one of the agents of natural disturbance. The next question, I suppose, there's a couple of questions left. And that is, well, what affects the grazing and browsing? What actually impacts on these animals which are driving disturbance? Well, of course, it's the top predators. And there's another natural process here, I suppose, which is the ecology of fear. I guess some of you have heard about this. The idea that big grazing animals, well, any herbivore, is affected by the existence of predators in the landscape. If you're a deer and there are wolves around, you behave in a very different way than if you're feeling safe. And in fact, one of the biggest problems in nature conservation isn't overgrazing or undergrazing, it's even grazing. If the whole landscape is grazed evenly, then actually it's much less diverse than if there's difference. And the ecology of fear drives animals to move on. It drives them to avoid some areas. In Yellowstone Park, when they brought back the wolves, they found that the deer avoided the edges of rivers. That's where they were ambushed. As a result, the edges of rivers regenerated. And what they didn't even realize how degraded the riverbanks were until they started to regenerate. It's an example of how fear drives ecology. And that's relayed in all sorts of different ways. So the ecology of fear is a driving force, which we generally don't have in this country. So, you can identify natural processes which are actually absent, we have to think about. The last natural process I'm going to mention actually it cuts across the whole thing, and that's hydrology. So what I'm basically saying is that this in red writing here, they are the 4 forms of natural process that we can probably think about when we're thinking about rewilding. Here we are. So the idea that succession is going in one direction, natural disturbance is going in another. It's kind of moderated or impacted by the ecology of fear. But on top of that, you've got landform, hydrology, the way the water flows, the way hydrology works. There are probably many others as well. We could talk about nutrient cycling, energy flow, all those sorts of things. But I think this kind of captures what the natural processes are that drive ecology and drive rewilding. Okay, let's move on. So, so you've got the natural processes working, you've got the succession fighting with natural disturbance. That should give you rich and diverse vegetation structures. And if you go to NEP, this is the sort of thing you'll see. In close proximity, you've got trees struggling to get going, probably be browsed, probably be killed, right next because of the browsing impact. So this is oak, probably a lot older than it looks. Right next door to that, though, you've got spiny shrubs. You've got roses, hawthorn, blackthorn, all sorts of things acting as natural defences to the oak. So you see the oaks, in this case, are starting to emerge through I think in this case, rose shrubs, and that forms a natural barrier. So you're starting to see a kind of patchwork, very close-grained patchwork of some areas with open trees which die, and therefore you have grazing land. And in between that, you'll see other areas where the trees are being protected, coincidentally, by spiny shrubs, and they're getting away. So you're starting to see the idea of groves of trees emerging within a grazed environment. Now, those groves of trees could be any sort of size. Here, they're 1 or 2 trees, but you can see much larger groves being defended by spiny shrubs. This is the sort of matrix you see developing in the NEP rewilding project. And this is what it looks like after a while. You see a ring of, I think in this case it's gorse actually, surrounding an oak tree which has got away, and it's going to be a future, big open grown oak tree. But this answers all sorts of questions. A lot of the biodiversity that lives on oak trees, and oak trees have the highest number of insects of any species in this country. A lot of the biodiversity that relies on these trees needs these trees growing in open conditions. There was a bit of a myth that oak forest harbored all of these oak species. Well, it doesn't. It does harbor some, but mostly these species need open grown oak trees. Now that's where you get the greatest biodiversity, and that's not explained by dense forests. So this sort of pattern enables the future development of open grown oak trees, patches of scrub, patches of dense woodland, patches of grassland, but all growing in close proximity, in massive complexity. And here's an aerial photograph of Knepp. This area here is an old oak wood. It's actually it's an ancient wood. If you come, I'll take you there. That's an oak wood, an ancient woodland, at least 400 years old, probably a lot older. The area to the right, that was arable land 15 years ago. And what we've found is that the trees have spread, jays have planted the acorn, mice have dragged nuts in and so on, wind-blown trees like birch have all established. But going against that, you've got browsers and grazers with this dynamic relationship, basically keeping it open. So the tree's trying to grow, the grazer's trying to eat them. And you get this patchwork. Everything that you can see there, even the little wiggly path, I think was created by herbivores. You get this patchwork evolving. And of course, you've also got pigs behaving like wild boar, opening up these areas, bringing the mineral soil to the surface, and starting another form of natural disturbance, followed by natural succession. You've got all this going on. And we used to call this a matrix, or a shifting matrix. The far better word for this is actually a kaleidoscope of shifting habitat. Remember those old kaleidoscopes, you look down, you see all the patterns and shapes changing, and the colours changing. It's much more like that than a fixed matrix, a kaleidoscope of shifting habitat. That seems to be what this sort of process creates. Okay, so the natural processes, you got your rich vegetation. One phrase that you probably know, the Professor John Lawton is a very well-known professor who develops ideas of landscape ecology. His phrase was, species keep you honest. You can have all the most wonderful theories in the world, but if it's not reflected in what's happening to the species, you've got something wrong. Okay, we've done all this stuff at Knepp, we've brought back the natural processes, we've got the vegetation structures, but what are the species telling us? Are we actually getting more species there? Are we actually getting the kind of diversity of different suites of species? Or is it just kind of a bit of a mess and nothing's responding? But what we found is, of course, there's been masses of surveys done there, and the biodiversity has responded incredibly. What we're finding, this is now old data. Over 30,000 records have been collected of over 3,000 species. By comparison, that's about the same number as most of our nature reserves have, and this was farmland 15 years ago. It's nowhere special. So about 3,000 species, notable species, biodiversity action plan species, red list birds, for example. There's woodcock down the bottom there, that they're breeding on site. So yes, we're getting a lot of species there, and a lot of really quite interesting species as well. It's not just kind of weed species that come and go. We are getting the species there. We haven't yet seen any fall off in things which are kind of losing. Things aren't losing out, but things are coming in, which is quite odd. There must be a balance met at some stage. And also Knepp is turning out to be a national hotspot for all sorts of species. Cuckoo, for example, its numbers are building up there. Turtle dove, which is in Sussex, I think throughout Britain, it's one of the most fastest declining birds. 98% loss, I think, since 1990. There were thoughts there might be some in Knepp. There are now 16 singing males. Similarly with nightingales, there was one singing male, I think, at the start of the project. It says 19 there. I think the recent figure is that there's now nearly 30. So all of these things are coming along. The purple emperor butterfly, we didn't even know it was there at all. It might have dropped in. It's now the most important site in Britain for purple emperor butterflies. It's got huge numbers of species there, huge numbers of the butterfly there. The point I want to make here, though, which is quite important, traditional nature conservation, and I'm not saying that's I'm not saying that's wrong or anything. Traditional nature conservation would identify what's important and then build a management plan to look after what's important. And that's completely the right thing to do in most cases. But that's not what happens in rewilding projects. What happens here is that a system is rebuilt. We rebuild the natural processes. We recharge the ecosystem. What happens is an emergent property. There is no management plan for cuckoos. There's no management plan for Barbastelle bat. There certainly isn't a management plan for purple emperor, but they're all important. And what this is the emergent property from a rebuilt system. It's not the objective delivered by management. A critical difference. Neither is right or wrong. They're in the right place at the right time. But it is a critical difference between rewilding, which is about emergent properties, having rebuilt a system, and traditional approaches, traditional management, which is about recognizing what's important and rebuilding and delivering the objective. Both important. Okay, that's okay. So we seem to be doing okay. We seem to be getting our species back again. Actually, in spades, there's masses of rejuvenation in the Nep estate, which, after all, 20 years ago was a pretty ordinary farm with nothing particularly outstanding there. It wasn't unpleasant. It was quite a good farm, but it was certainly not outstanding. It is now. Okay, so the species are there. But is the ecosystem functioning in a way? Is it a better ecosystem, whatever that means? Now, this is a big subject. I'm not going to speak very long about it, but there's a lot of work going on to work out, well, what do we mean by ecosystem function? How do you measure it? How do you say whether something is performing better or not? Biodiversity, the species, that gives you a very good clue, but actually there's more to it than that. But actually, perhaps the best way to find out about this, to see whether it's actually functioning or not, is, well, it's all in the soil. If your soil is functioning well, if your soil is building up, then the odds are your ecosystem is functioning pretty well. And the point of that Nep is this is being closely monitored, as other rewilding projects have, and we're finding that the soil is recovering far faster than anyone predicted. So, for example, there are places right next door to Nep which can end up in the rewilding project, so they act as a control. So you can compare what happened in Nep with some land which, as far as we can tell, is on a similar, in a similar kind of biome. So what's the difference? What's changed? Well, in just 15 years, soil carbon has more than doubled. Now, I don't think we realized that was possible. More than double the amount of carbon in the soil, more than double the amount of organic matter in the soil. Apparently there are soil microbe biomarkers that you can watch, and these are recovering. I heard a statistic a while ago, which is so amazing I can't forget it. The question is, well, what does a recovered soil look like? And the soil scientist told me that if you take a gram of soil, which is a bit less than a spoonful, I think, in that gram of soil, there could be 10,000 species of microbe, 10 billion individuals, and more individuals than there are people on Earth, 10 billion individuals, and 50 kilometers of fungal thread. Can you imagine that? 50 kilometers of fungal thread in a spoonful of soil. That's what a real soil ecosystem looks like. I don't know who counted them, but there we go, another job. Also, of course, looking at, well, what drives some of this, and dung beetles are really important in this ecosystem. And comparing Nep with an organic site, you can see this is numbers of individuals. In a sample, Nep nearly had 12,000 species, 12,000 individuals in the sample, whereas a comparable organic site had about 600. Now, you could say that's perhaps not a fair comparison because the organic site may not have had the same kind of interaction with animals. But actually, it makes the point. Rewilding, interaction with animals, the importance of dung, the buildup of carbon in the soils, it's all linked, and it's all an indication of the functionality of that ecosystem. So what's the importance of soil? What's the functional importance of soil? Well, it's pretty obvious, I'm sure we all realise. Amelioration of water flow as it goes through the soil, the enhanced stability, reduced erosion, the aeration and permeability of the soil, infiltration rate, the way water seeps into the soil rather than washing straight off. That's all improved if you have a functional soil. Obviously, it's the rooting growth. It's a rooting medium for plants, so that's important as well. So soil has a functional importance, reflects the functionality of the ecosystem. I suppose, linking to what I said earlier, rewilding is actually a way of thinking. It's not just a definition, it's not just a particular thing, it's a way of thinking, which is actually in fullest extent fundamentally different from traditional, what are called traditional conservation, for want of a name. And as I said before, it's process-led. Rewilding is actually about putting the processes back in place and as much as possible allowing nature to take its course, so that low intervention. So it's about, it has to be large scale. So it's about putting processes back in place, trying to be as non-intervention as possible, and allowing things to evolve in their own way, so emergent properties. That's rewilding. However, the other approach is more outcome-led, where you could be looking at natural processes, but actually your management is copying natural processes and delivering an outcome, delivering an objective, which is something that is important on that site, which is a different approach. That's traditional sympathetic nature conservation management. So these are two different approaches. They're right in the right places. I certainly don't subscribe to the view that one is right and the other one is wrong. They're both two sides of the same coin and can inform each other. So they're quite important. And you can probably spot they overlap actually in practice. In nature conservation, we were well before rewilding. We were thinking about natural processes and how they actually work and how we can restore them. Okay, so where would you and where wouldn't you do rewilding? There's sometimes a bit of a view that it's the art that we must do it everywhere. Well, we should consider it everywhere, yes, but I think there's more to it than that. And actually, here are some of the considerations. If you're doing something radical like rewilding an area, you should probably do it on land of least risk, because we don't really know what rewilding is in practice. We don't know what the wild is. There's so much unknown about this. So do it on land of least risk, where there's no or very little special sensitive wildlife. Sometimes the sensitive wildlife is linked to the way past management has worked. You'd probably do it on land of low agricultural value. Doing it on high agricultural value land is well, it's a bit of a risk for agricultural productivity. There's plenty of low value land out there as well. If your objective is forestry, then you would do forestry. You wouldn't do rewilding. If there's land with a clear objective, that is probably where you wouldn't do nature conservation. Those objectives might be agriculture, forestry, but they could be biodiversity. Your objective may actually be to look after, for example, looking after bitterns in a reed bed. So therefore, you have an objective. So it's probably not where you do rewilding. So there's a right place and a wrong place to do rewilding. Scale. The question we're always asked in these courses is, how big does a place need to be rewilded? How big should a rewilding project be? My answer to that is, it's the wrong question. If you can't think of a good answer, then you should always question the question. And that isn't the question. The question is, what is the area needed to support the ecological process you're trying to restore? And that gives you a better handle on the size you may need. Now, I'm going to talk you through this, starting big and ending up small, because it's fun apart from anything else. So let's start big, about all natural processes, starting right at the top of the tree. What's the area required to support top predators? What's the area required to support a population of lynx? Well, the lynx has the biggest territory of any cat in the world. You're going to need a big area. If you want to get the ecology of fear back working and you want a viable population of top predators that drive it, you're going to need a big area. And to get these things back, all these chaps, you're going to need a vast area. Somebody said once, if you introduce wolves to Scotland, you should tell the people of Cornwall that they're on the way, because you do need a huge area. You need region to bring back your top predators. I'm not ruling it out at all, because the same principle also works for some of the lower predators, but you need large areas, obviously. You're going to need whole regions, hundreds of square kilometres. Maybe that's not on the card for this country, but let's not write it off entirely. So you need large areas. Okay, moving down a bit, let's think about interacting wild herds. This is Aspartusplassen in the Netherlands, where these animals are treated as wild. They're not domestic proxies. They're left to sort it out for themselves, which is controversial. What area do you need to have herds? There's no top predators here, which is another thing. But how big an area do you need to have all these herds interacting with each other? It is a wild auroch equivalent. There's also ponies there, conic ponies and red deer, all interacting with each other. How big an area do you need? You need a vast area again. By the way, the wild auroch, do you know the wild auroch? It's an extinct form of cow that our cows came from. The wild auroch, if you imagine the biggest cow you can imagine, probably something like a charolais, Put 6 inches on the shoulder to make it bigger and give it a really bad attitude. That's a wild auroch, and there were herds of these things roaming around Britain pre-Roman. This is a bred-back version of it. You don't want to go too close to these things, but they're not as big and not as savage as a true wild auroch would have been. So if you've got wild herds of these things around, you need a vast area. You've got these interacting animals like wild boar as well. If you're going to have a viable population of wild boar, with all the disturbance I talked about earlier, again, you're going to need a large area. With all these things interacting, some of these things we may get back again. Bison, it's thought, weren't present in this country in this interglacial, but they were in Europe, and that's the same ecology. If you've got all these things interacting, you need a big area. You're going to need at least 10,000 hectares, probably more. Asvardus Plassen is 6,000 hectares. It's probably not big enough. So you need a vast area. Maybe that's off the cards for Britain, certainly at the moment. Move down a scale. Let's think about these domestic proxies. These are our nice, friendly animals that we're used to. Yes, they are domestic. We are responsible for them. We have to make sure they don't suffer, which is fine. But so they're not wild. But very quickly they learn to react, to behave in a very wild way. And then you're getting a little bit more flexible. You can actually have a smaller site. You can start to make sure these things are working. The level of intervention you have to put in goes up because you're actually, to some extent, managing these populations. There's no intensive management here, but you're watching them, you're being careful, you're making sure things are okay. You're probably going to need something like 1,000 hectares. More would be better, but the block in NEP I was talking about is only 800 hectares. The whole of NEP is 3,500 acres. I'm getting the acres and hectares muddled up, aren't I? This is hectares. The block in NEP is only 800 hectares. The whole estate is about 1,500 hectares. Okay, so you need about 1,000 hectares, really. If you go down a scale again, and okay, so you want your grazers and browsers there all through the year, but maybe you haven't got the space for all these interacting properties. You're going to need to have you can get by with a smaller area, maybe a few hundred hectares. We're starting to get to the size of a normal nature reserve. And there's a change in attitude. Large scale, we're thinking about, well, what size do we need to fit processes? Small scale, we're thinking, well, how do we manage the process at the scale that we actually have? Okay, going down a scale again, smaller areas, you have to manage the disturbance to fit the space that you have. And it starts to look a little bit like more normal nature conservation. You may have layback land, areas where you put your animals because they can't be on site all the time. You've got naturalistic grazing, like with these belted galloways down at the bottom here, where it's more like a rewilding project, but you may have to take the animals on and off the land according to how big the site is and whether it can hold them all through the year. We do that in the Sussex Wildlife Trust on some of our nature reserves. We get very similar outcomes to NEP, but on much smaller sites because we're trying to copy rewilding. You may only have a few tens of hectares, maybe less. And what about if you've got a very small place, you can't get any animals in there, and you have to do the rewilding yourself and pretend to be these animals. You have to pretend to be a, I don't know, you have to pretend to be a bison and go there and cut stuff. You have to pretend to be a wild auroch and go there with your reciprocating cutter and graze an area. You could say there are 3 different rationales for this sort of management. A long time in the past, this was about getting a product because it was commercially viable. In the more recent past, it was about delivering a conservation outcome with traditional nature conservation. You could now say that actually what we're doing now is reproducing or recreating a natural process. We're pretending to be a natural process. There's a different rationale again. But actually notice it's the same management. You've got 3 different rationales. And also, let's not forget the grazers that are probably roaming around anyway. Some urban rewilding projects are quite small, but pretty effective, because actually there's so many native grazers going through there anyway. They're creating the diversity without any need for kind of hands-on management. Okay, a few hectares. Other factors influence size. Geographical variety, hydrological variety. If you've got a lot of that in a small space, you can have a smaller project. Also productivity. Highly productive areas, or more productive areas, you can fit bigger populations of animals into a smaller place. So the south of England can have smaller rewilding projects than the north of Scotland, where productivity is lower. Okay, I just thought I'd drop this diagram in here because this may be relevant to some of you are thinking about rewilding in a local context with local sites. What we tend to do with our small sites is we have a management objective. Quite correct. So at the bottom there is what we tend to do. If you have a large landscape, a rewilding project, you haven't got a specific objective. No rewilding project is big enough and complete enough to leave it completely alone. So what we do there is we have limits of acceptable change. We try to make them as wide as possible so nature can move and change and be dynamic, but we also have to watch to make sure that it's within limits of acceptable change. There's always decisions to be made. What we can do is halfway up this scale is as nature reserves, for example, get bigger, then you can start to have multiple objectives. You can manage for multiple objectives. Gets bigger still, you can start to have adaptive management, fluid objectives. Change your mind every now and then as things change and evolve and become dynamic. I think sometimes in nature conservation, we've tended to stay at the bottom end of this. We tended to want to have very specific objectives and deliver them. Very often that's completely correct. But actually, as we're rebuilding systems, we could perhaps be more fluid, more multiple objectives, start to have limits of acceptable change rather than narrow objectives. So I'll leave that perhaps as a challenge, the way we can actually think in nature conservation. Okay, this is just a little bit of a graph that, again, actually comes from Professor John Lawton, plotting the size of sites against management intensity. And down at the bottom right then, you've got huge sites with low management intensity. At the top left, you've got smaller sites with high management intensity. Most of our sites are in the top left, but the really big sites are in the bottom right. You can see NEP there in the middle, where we're trying to get a bigger site and lower the management intensity. So that's rewilding. I'd like to take you to NEP one day. That would be great fun. But thank you very much for having me. And if there are any questions, I'm very happy to answer them.
Well, thank you very much. Over to you, Christina.
So yeah, so thank you, Tony. That's been really excellent. Lots of thought there, things to think about, certainly. So has anyone got questions? Anyone like to ask Tony anything? Ched there. Yeah, Ched, carry on.
Hi, Tony. Based on some things I know quite a bit about to things I don't know anything about. I was interested in a bit about dung beetles. You've obviously got a mix of animals there. Presumably the ones that are looked after well do not receive any ivermectins or anything to kill the nasties that come out in the dung.
Yeah.
Is the situation working because you have a balance of animals that have different parasites, or is it because of a low density? Or can you comment on what the helminth situation is in these animals?
Yes, it's a very good question, and there's a lot to that. They are lowish densities of animals. They are not treated with chemicals at all if we can get away with it. In fact, they're very healthy animals, so they don't need treating. We don't use ivermectin. There's a vet very closely watching us because NEP's known about and we can't have things going wrong. So it's very well followed by a vet. No, we don't have the chemicals and we don't have the ivermectin interfering with that dung cycle. We do have a mix of animals, and the way they interact with their vegetation seems to be important. And we're monitoring the actual species as well, as well as the actual numbers. And so, for example, we've had I'm not a coleopterist, so I don't know the details, but we had, for example, violent door beetle, which I think is a rare dung beetle thought to be extinct in Sussex, which came back. And now it seems to be in quite high numbers there. So it seems there's now a suite of species associated with dung, which seems to be coming back and doing its ecological thing. So it does all seem to be working together, and it does all seem to be linked. I don't think it's one thing or the other. It's not just the absence of chemicals, and it's not just the mixed animals that are there, and it's not just the interaction with vegetation. It's all of it working together.
Good, thanks. Yeah.
Okay, has anyone else got any questions?
How close to rewilding are some of your sites in Ruislip?
Yeah, so that's what I was going to say. Quite a lot of us on this call are involved with different reserves. I think all of us on different ones. And I'm sure it's given us lots to think about those reserves that we actually help manage. For me, I mean, my local one is Maple Lodge, and a few things you've said have made me think about it because, well, firstly, we have a lot of trouble with loss of understory, and that's due to wild deer. There's a lot of deer, muntjac particularly, that are causing that. Then also the walk we went, the Natural History Society did a walk last weekend, and we went to Hodgemore Wood, and one of our comments as we were walking through the wood, there the understory is mostly holly. Now, would you think that leaving holly is actually a good thing? Because most reserves, and I know Ruislip Woods particularly, they would try and remove as much as the holly as possible, but maybe from what you say it'd be a good thing to leave it.
It's such an interesting question, because I'll answer it in a slightly different way. If you go to NEP, what you tend to see is the that evolution that I told you about, where you get these groves of trees evolving. But what you'll also find, if you go into the ancient woodland that's there, is it's being eaten away. So it's all, you know, you can see through it, like in your worst example of an ancient woodland, and you think, oh, isn't that terrible? And actually, by itself, it is terrible. But what we're finding is that the ancient woodland plants are reducing, but they're not disappearing. But what we're finding is that those ancient woodland plants, which elsewhere don't colonize, are appearing in the scrub next door. So it seems that what we've got in a functioning landscape is a shifting mosaic. Now, we don't usually have that in our nature reserves or in our landscape. You only have the bit that you've got to look after. You can't afford to lose that, and you haven't got the dynamic process. So something like holly is usually a rebound after grazing stops. So you see it in the New Forest, you get holly coming up, and then it forms this dense kind of, I think they're called ringwoods in the New Forest, which tends to exclude things. And eventually, a couple of hundred years later, they fall apart. They literally fall apart, and you get something growing up in the middle. That's great as a natural process. But actually, in most nature reserves, most landscapes, you haven't got that dynamic to actually have all the stages that you'd need to have all your biodiversity. Therefore, you have to manage. And you just get the question, what do you do with it? Maybe, well, the thing about management is you can get a corpse into a pint pot. You can get more diversity into a small space than would happen naturally. And that's just as well, because that's what you need to do on small sites. So you're brought back into having to manage. You can pretend to be a natural process of some sort. You know, have a go with it and pretend that you're being a fighting deer or something. You can pretend to be a natural process.
Yeah, so I suppose that's it. I suppose most of the reserves that most of us manage, they're too small to be completely natural.
Absolutely.
Therefore, this is why we have to manage them ourselves. Yes, that makes sense.
Yeah, all places are way too small. And one thing I didn't say earlier, which I should have said, is that rewilding is not the same as abandonment. And some people think it's not the same at all. Abandonment is a passive letting things go to whatever state it was in. Rewilding is a positive decision. It may involve abandonment in some places, but it's not the same thing as abandonment. You have to positively think about what natural processes should be working there, therefore what are you going to do about it.
Yeah. So another point that came up that I thought about while you were talking. So we were talking about obviously dung beetles and your cattle and leaving them naturally, but do you have to manage it to remove things like ragwort? Because obviously, you know, where I've had horses, it's always this big thing, and on the reserves about, oh, we should remove ragwort, and then there's always this debate about, oh, it should look after itself as long as you haven't got animals eating it, or they should recognize it as long as it's not cut, that sort of thing. So do you have that problem at NEP or not?
Ragwort discussion is amazing. Yes. It's a sea of yellow some years. It's completely covered with ragwort, and we have no ragwort poisoning.
Right.
Literally none. There's no hint of ragwort poisoning anywhere. Animals aren't as stupid as all that. They know not to eat it. It's a controversy for several reasons. First of all, people were accusing NEP of allowing it to blow onto their land, which is a fair criticism. So, being a big landowner, of course, he got the national expert on ragwort on his advisory committee. And I didn't realise that ragwort actually doesn't colonise very far. It only colonises about 50 or 70 metres. Apparently, if you've got ragwort, it's probably the seed already in the soil. The stuff that blows around probably isn't viable. That's why it's light. So to answer the criticism, he mowed an area 100 metres wide around the edge of the state to answer the criticism. Fine, but the trouble is, what we have to realise is that people sometimes see ragwort as a bad thing anyway. It's a sign you're getting it all wrong. So you have that kind of emotional thing to go with. Actually, this has come up with several species. Ragwort certainly came up with creeping thistle. There's masses of creeping thistle. Eventually, it sorted itself and died down. But again, it was referred to. Knepp was referred to as the biggest weed farm in Sussex. So there's these kind of perceptions that you have to fight your way through. But no, ragwort. We're now seeing this as a very important plant. It's a big nectar source at a major time of the year, and it seems that it supports a lot of things. You can see the cycle of nectar going through the year at Knepp because it's evolving the way natural systems would have evolved.
That's interesting. Yeah. Right. The other question I was going to ask you actually is you mentioned about beavers. Is there any thoughts to bring beavers back at Knepp, or is that?
Oh yes, we're going to have beavers back again. We're absolutely can. We did try once. You may have known that they were brought in, and we had a particular fencing strategy, which, let's be fair, failed dismally, and the things got out. Bad news is they got out, and they weren't supposed to because that's part of the license. Good news though, they escaped. One of them escaped into a fishing lake, and the fishermen loved it. They didn't want to give it back again. The other one went the other way. They didn't like each other. It turned out, but never mind. The other one went the other way, went downstream, and appeared in the middle of the farmer's field, and was chewing up everything in the farmer's field. And he was delighted as well, and is insisting that he was involved in the next release program. So we had masses of I think there was something like 70% of the responses were highly positive, and about 15% were antagonistic. So vast majority, including landowners and fishermen, and all the people who've been told would be against it, very, very positive. So there were good sides to it, but we haven't. So there is a plan to get beavers back again. Shouldn't be too long now.
Yeah, well, that's interesting. That's good to know. Yeah. Well, thank you ever so much. I don't know if anyone else has any more questions that they want to add or no. Right, I think we'll say thank you. I don't know if we can all show our appreciation by showing a clap.
Thank you very much. Thank you. Thanks very much.
Really good. Lovely.
Thank you very much, Tony.
Maybe see you physically one day.
Yes. Thank you. Bye.
So we'll call the meeting closed then, Christina.
Yeah, I think so.
Okay. Thank you very much for everyone's attendance.